Hey there! In this video we are embarking on an electronics bonanza. We'll see how implementation of layout command control has been done on this layout. And this video is not really intended to be a tutorial, more of a, as I said, implementation process specific to this railroad. But if you want to find out more about layout command control, you can head over to nmra.org and read all about it there. There are other resources on the net. I mean, there are videos on YouTube, and there is an OpenLCB developer group as well as an LCC user group on open groups or groups.io, I'm sorry. And you can read there, and there is discussions about LCC elsewhere. The more time goes by, the more you will hear about LCC, as that's a new standard basically from NMRA that extends the DCC, and there'll be more and more things in the future, both from the manufacturer side and from the enthusiasts and hobbyists. So let's just jump in. I've bought some of the other circuits, LCC nodes and other accessory boards for the staging deck on this layout, as well as I had to get some Cat5 cables, which are standard use for connecting these LCC nodes. Each node would have a Ethernet lookalike port, but it's really not an Ethernet network, it's a CAN bus. Another thing you'll see here is this ESP32 based command station. This is a custom built command station from a project on GitHub, and I'll put a link in the description. This command station runs an OpenLCB based framework called OpenMRN, or Open Model Railroad Network, which is available from GitHub as well. I'll post a link in the description. ESP32 command station was not the only option here. TCS, the company that you're probably all aware of, has a CS-105, a commercial LCC command station which will run all of your nodes and all of your accessories, as well as connect to your LCC Throttles, like their TCS is UWT100 and UWT50. So let's get going. Another better than a clean slate, an empty piece of plywood that's been painted and ready for electronic pieces. You're going to see some of the wires hanging there. Those are the feeders from the staging above it. Don't worry about it. This white box in the corner is a power point for LCC nodes. That's what provides power. It injects the power through the LCC network, through that Cat5e cable. This is a laptop power supply I use. It's a 7.5 amp, 16 volts or something like that. It doesn't really matter because it gets regulated afterwards and just connects to the power bar. And the other one is the adapter for the other circuits power point. There are some tools and LCC nodes, custom made boards, cables, all the kind of things that you'll need to put the electronics panel together. Most of you have done this to some extent already on your railroads when you were putting together your DCC accessories. Here I've already started putting some of the electronics boards on. The command station is in the lower left, it's powered, and above it is the PSX1 circuit breaker. And then above that, the black chocolate bar block is the phenolic terminal block. They're very useful for connecting wires of high thickness. The gray piece of plastic is called the SnapTrack channel. It's a model 3TK2, and it's used to mount all the other circuits nodes. All of their nodes have been designed in the same fashion, so their dimension fits into this channel perfectly, and connecting them is just a breeze. Further down the road, more nodes have been mounted, and you can see short Cat5e cables connecting the nodes. That white board in between these terminal blocks is the capacitor discharge unit, and now you can see all the other circuits nodes and how they mount in this channel. They're pretty close, but there's enough room to run the wires and whatnot, and you can use just short jumpers. These blue and red boards are custom made Railcom block occupancy detectors, and you can see also the PSX1 connecting to the power and powering those two boards as well. That's all going to go up there eventually when I put the long phenolic terminal block at the top of the electronics panel, and then run all the wires along the bottom of the staging deck. The feeder wires will connect to these blue block occupancy detectors, and the turnouts will be connected to the other circuits SCSDs. And I'm using Atlas turnouts, so they're dual coil ones, and that's why the capacitor discharge unit is there to drive those coils when they're flipping. Moving right along, now the feeders have been connected to some of the bus runs, and as I go I label them. You can see there is ladder 1, 2 and 3, there is east and west maintenance of way, and there's also a 3-way. These are the wires that connect to the turnouts, and then here is a frog juicer, a dual frog juicer, because I have a 3-way turnout at the throat of this side of the staging yard. Now taking a look at this board. This is a Railcom board, so it has a Railcom detection as well as block occupancy and circuit protection and powering track on and off. It's a 6-channel board. It's a custom design from one of the OpenLCB developers. He was gracious to let me have the design and replicate it on my layout. Taking a stroll now underneath the benchwork, you can see all the feeder wires have been connected for all the tracks above. Those 2 wires hanging at the end, they're actually a power feed that will go through the wall to the other side, because there's going to be another panel there with just less electronics, but it's needed to drive all the turnouts on that side of the benchwork and that side of the staging. The way I wired this is that this panel is the main panel. It hosts the command station, and it also powers the entire staging, both east and west end. So when you turn this on, all the nodes come up, all the power for the rail goes through the main bus and goes through the wall to the other panel as well, and that will power on automatically. While at the same time you can only turn the staging on and not turn the other power districts. Here we see those white wires that are bundled together. Those are the control signals for all the turnouts, and they connect to the SCSD8s on the SnapTrack channel, that gray piece of plastic, and then above these are all the Atlas turnouts with the snap coils, or the dual coil ones. So each one of them needs 3 wires. Well, the one common and then 2 poles. Then I had to custom jig the 3-way, because this is a Pico 3-way. It does not come with any coil motors. So I found these old coil motors in my local hobby shop, and I end up just gluing them to the cork here on the benchwork, and then rigging some wire that sort of is flexible and then connects to the throw bars. And it kind of works, sometimes it's fiddly, but it might need some tweaking. I mentioned that other control panel, and here it is. This is the other side of the staging. This is inside the layout room, and it's a similar configuration. There is a capacitor discharge unit, those phenolic terminal blocks, and then I have 2 nodes and 3 SCSD8s. The nodes, one is a tower LCC and one is a signal LCC. They drive these turnouts here on the, I think this is an east side, and you can see all the wires from the coils coming down, and then the trains will auto stage or auto restage. Basically, just it's a through staging. You can see a train here. This was a temporary main line that I laid, so I can test the trains and the work of the turnouts and the actual panels, as you can see. And now the entire staging has been wired and powered and block detected, and all the turnouts are remotely controlled. So this is the west side. Well, that's eastbound. That's the east side of the staging. That's westbound. All the turnouts are wired.
connected to SCSCDs over there. It's an SCSCD8. I got the tower LCC and single LCC. I have 3 Railcom I/O boards. They are block occupants detectors. I have a PSX1 short circuit protection, capacitive discharge unit for this area. I also built another voltage regulator so that I can control the command station's DCC output voltage. So I actually have 12.5 actually volts coming out onto the track, and I also have a frog juicer, dual frog juicer, because there is a 3-way with electro frogs at the throat of the west end, and you can see some wiring all over there. And then there is that 3-way that I've MacGyvered some solenoid motors to it, but otherwise as you can see, the number boards are lit up, and there is power on all the tracks, including the sidings. And then inside is the other panel. It is also wired up. It controls these turnouts here. It's a less complex one, so there's just one Railcom I/O board, another CDU. I brought the DC 18 volts from the other end, and also DCC, which powers and drives the turnouts in the Railcom. And I also have 2 power LCC and 3 SCSD8s. They control the solenoids.
And here you can see a simplified diagram of how I wire these together. The upper right are the Atlas dual coil motors, the upper left is the CDU, the capacitor discharge unit, and then you can see the SCSD8 at the bottom and how it's all connected. And here is the CDU, the capacitor discharge unit. It's a standard circuit found on the internet. If you want to pause it and take a look at it, it's nothing special. I just took a piece of copper clad board and then cut the traces with the X-Acto knife. It wasn't anything etched or whatnot, and then drilled the holes and mounted all the components on it. But it works, so that's all it matters. And to geek it out even more, here is the configuration view of the node for one of the coils. Actually, it's 2 coils because you have one side and the other. And this is view of the CDI, or the configuration dialog interface from JMRI. You can find the information about configuring the tower LCC or the signal LCC on the R Circuits website as well. If you want to inspect these figures more, you can pause the video now and look at some of these settings. They're really nothing special, they're just standard values used to drive the coils. After finishing the staging panel, I built 2 more panels for the power districts 1 and 2. What's interesting about this is I'm using Lens LV103 boosters, and in the upper right corner you can see a Cat5 cable for the LCC network, and what it does is it's bringing DCC signal to the booster. So I don't have what normally people have, a DCC bus running all around the layout. I actually only use Cat5e to bring the LCC bus or the network to all the points on the layout, and it carries the DCC signal with it. This is not an amplified signal, it's just a digital source that the boosters then convert and amplify and locally distribute to the power district. So my bus run for the DCC is much shorter and the signal loss is greatly reduced than normally when you run the DCC bus all around your layout. These 2 power district panels are still incomplete. They need more nodes, and since the layout has not been finished, I'm not sure which nodes will go where yet. After this, I built another board and added it to the main panel in the staging where the command station is. This is a Wi-Fi LCC gateway. Its purpose is to connect your wireless throttles via Wi-Fi to the LCC network. And if you have an LCC throttle like the UWT50 or 100, it will work in the full LCC mode because it will detect the LCC command station on the network. Wrapping up here, I'll leave you with this shot. This is the finished main panel with all the LCC nodes and components in the west staging, including the command station, the LCC Wi-Fi hub, those Railcom IO boards, PSX1 and whatnot. If you want to pause the video and just study this more, you can. If you have any questions about LCC, you can leave them in the comment, or you can come to the OpenLCB developer group or the LCC user group and ask your questions there. There is many knowledgeable people always reading those questions and trying to answer anything they can and introduce the users to this new standard, which is going to be, in my opinion, something important going into the future, as the features it offers are greatly enhancing the experience that we are having in model railroading. As always, I hope you liked the video. Thank you for watching and stay tuned for more.